we formulated a roundtable of all the division managers, as well as subject matter experts and stakeholders external to the wastewater enterprise that would probably have a say in informing our research and development, and also might be potential partners. So our power enterprise, our finance bureau, community benefits, making sure that we consider the societal impacts and benefits of the research that we choose to move forward with and what we're attempting to accomplish. And then our water enterprise as well, really focusing on the one water concept, which I'm sure now is pretty, it's a pretty common term, but 4 years ago, that was a relatively new concept coming out of the toilet to tap efforts. So the roundtable goals were not just to focus on research and development. It's really about the people, and it's about organizing and focusing our efforts, because we have very limited staff, like everyone, very limited resources, and we wanted to make sure that not just that we were doing things right, but that we were really doing the right things. So we have 4 goals, and normally I don't read from a slide, but I am going to in this case because they've really created the guiding principles for our research programs and this roundtable. One is that we want to, of course, keep an eye on the resources entrusted into our care, and this is really important. A lot of people have heard resource recovery as a concept. Do people nodding? Have people heard of resource recovery in the wastewater sector? Okay. Well, to what end? So if you're not recovering resources to reduce the amount of resources that you spend money on, like concrete, electricity, potable water, staff time, then why are you recovering resources? What's the point? So we really wanted to make sure that we're asking the right questions. What problems are we trying to solve with resource recovery? And that meant really looking at the resources and the ins and outs of our plant, the inputs and outputs. The next is building strategic thinking acumen within our staff. We wanted to start getting people really thinking about what we were calling the family business, to walk around the plant as if they were an owner. And how would they run the plant differently if they had to pay the electric bill? What decisions would they be making differently? The next is teach staff at every level about the organization by making practices and decisions transparent and available to everyone. This was really important. Most of the resource recovery efforts and pilots really were made, the decisions to move forward with them were made in the vacuum. They were often verbal. There was no documentation as to why one pilot got funding and another didn't. There was no understanding of whatever happened to that pilot. What were the results? Did we learn anything? Was anything incorporated into our business practices? So I'll go more into that. And then also, and really importantly, to act as a vessel for professional development. We wanted to invite subject matter experts that were in the field to the table with the decision makers that are responsible for the actual budgets, so that we're making the right decisions that actually have impacts in our processes and ultimately our bottom line. So the first thing that we did when tackling innovation is we go back to that question: what problems are we trying to solve? Why innovate? When you have all of these different technologies that you can pick from nutrient removal technologies to biosolids conversion technologies, why pick certain things? What's the order of operations in prioritizing where you invest your funds? And what we decided to do was we categorized our research and development into these 5 categories. And they're presentations in and of themselves. But in short, we underwent a full-on in-house assessment of each of these categories. And we understood what our vulnerabilities were and what our opportunities were with each category. So for water, of course, you're thinking about nutrients. You're thinking about potable water. You're thinking about regulatory legislation that's going through every year in the California Assembly around zero discharge. For biosolids, you've got SB 1382 that's phasing out organics in landfills. How prepared are we to not send biosolids to landfill during the entire winter season? We weren't prepared at all. Biogas, we generate a lot of it. We're not very responsible in making use of it, even though we do have cogeneration. It's down 90% of the time. Nutrients ties back into water, and then optimization sounds like a catch-all, but there are so many really great ideas that come from plant operators and maintenance staff that go nowhere. And we wanted to make sure that there was a way that good ideas could be captured and at least evaluated to a first-degree level, and people that asked that offered those ideas heard back. So once we identified through these assessments where our vulnerabilities were, then it was easy to talk to staff about go out to conferences, find good ideas on these key issues, bring them back, and help us be a better utility. So what we did to organize all of these ideas is establish teams of subject matter experts for each of those categories. They pretty much involved engineering, operations, and maintenance staff. And the subject matter experts were the ones that would allow really great ideas that came through topic cards to go to the next level of evaluation. So these topic cards are a way for people to fill out something either online or just using a piece of paper and dropping it off at Minnow Fisher's desk to focus the innovation around great ideas and be able to make sure that anybody that either had access to a computer or didn't could come up with an idea and submit it. So the topic card, I know this is tiny print, but essentially the topic cards asked 6 questions. They all really revolved around what problem are you trying to solve, what's already been done around this effort, and how would this make the SFPUC a better utility. And keeping it on that level and just having people use their own words or having technology providers fill out the topic cards themselves, that was fine. That allows us to start not only taking in good ideas, but curating a site where we would have these ideas accessible to anybody that was interested in finding out what's out there for biosolids. What has the PUC already done? What have we tried and failed at? And most importantly, with 2 questions, is it right for the PUC, and is it right for the PUC at this time? And a lot of times we found really good ideas that just weren't right for us at this time. Nutrients being a very good example.
I'm not a vendor, but I have a question. Did you say, or would you allow a vendor to fill out something like that?
100%.
100%.
Yep. Yeah. We encourage the vendors because, I mean, if anyone's in sales, like, you know your business better than the utility knows your business, and you would like to articulate why you think you can solve a problem. And it saved a lot of time. We're actually going through that process right now with a vendor, and they're providing us with a lot of information. If we were just to look at their concept unilaterally, we would have dismissed that idea outright. But allowing them to understand our objections and overcome them and clarify, it takes a little bit of time, but you'll see it's worth it because I have a pretty good example of that. Thanks for the question. So if you get through a topic card and the subject matter experts say, there's something to this, we should spend some time, then the next level is a prioritization memo. It's a lot more detailed. Again, we're happy to work with the vendor on this prioritization, but essentially we use the memo for 2 things. One is to help the vendor and the champion of this idea internally, someone that really wants to see this happen, be able to put forth the idea in a way that's compatible and congruent with our decision-making structure, meaning that this prioritization memo is structured in a way, in the same exact way that we would give a presentation to our commission. So when you give a presentation to the commission, you fill out an agenda item, and it's very specific. They ask very detailed questions so that the commission is used to weighing apples to apples in a similar fashion. For example, they always ask the question, what are the consequences of inaction on this topic? Well, if that's the first time you've heard of it, then you're kind of thinking on your feet in front of the commission, and we didn't want to do that. Instead, we wanted to have associate engineers, journeyman level, even apprentices be able to develop an idea all the way to, if they were asked by our assistant general manager to present in front of the commission, they'd be very comfortable with the dialogue and understanding what questions are going to be asked of them and how to respond. So that goes back to professional development, because a lot of times the decisions that were made at the commission level weren't really accessible to most people in the field. And it's not rocket science. We just had to explain it. So what we did is we created a template of 6 slides that would take that prioritization memo and then put it into the actual slides that go into a commission presentation. When I say commission, we're governed by a commission, very similar to East BAYMUD's board. And this allowed anyone to be able to put forth a presentation that was crisp and clean and got to the point and was going to be viewed alongside other, in a similar manner to other presentations, so that the merit of the idea wasn't lost in the communication. So I wanted to give you an example of a real-world process that underwent this prioritization process, and that's the list deck. It's a biosolids conversion process that takes biosolids that have already been undergone digestion, and then further processes the biosolids through thermohydraulic process. It's essentially heat-assisted lysing of the biosolids to kind of like a NutriBullet liquefy biosolids so that they can be labeled as a liquid fertilizer and injected into fields, which allow biosolids to be spread out in fields longer throughout the year so that we're not sending biosolids to landfill. Great idea, but it needed some work because we had never seen biosolids injected into fields in California. That just wasn't done. So we heard the concept initially. All right, good idea. It did get through the topic card, but it sat for a little bit. The prioritization memo said, absolutely a great idea for the PUC, but not right now. There are no companies that actually do this. Farmers aren't used to it. It's expensive. And so what happened is that this really great idea went into a topic card library, and then each year it got revisited. So every time an idea is captured in the topic card library, it doesn't go into an abyss. We actually revisit a lot of these topic cards. Has anything changed with this company? And in fact, a lot of things have changed. The company located themselves in a partnership with Fairfield Sanitation District. They had shown that they had a handful of farmers that were very interested in liquid fertilizers. And so then that prioritization memo was rewritten and a commission presentation was put together. So again, this isn't for you to read. This is just for you to take in an idea that we went from about 26 steps initially to 6. To 6 steps that go from here's an idea to here's $3.5 million to make this happen. Or here's a line item in our budget in perpetuity to pay for this service because we're going in this direction. And that's essentially what happened with this ListTech product. We still have a valuable partnership with ListTech to this day. We started out giving them about 3% of our biosolids. We're pushing 25% because we want to get out of landfills. And we're also very interested in the fact that ListTech is selling their fertilizer to farmers because we pay farmers to take our biosolids. So I'm going to pause for a second and probably pretty much wrap up. I do want to say something very, very important if there's one thing that you get out of this, and that's that really great example, but probably the biggest benefit that we've had with this innovation platform is learning how to say no, and learning how to say no defensively. Really important. What happens when we say no to a lot of pretty good ideas? It means that we have the money to invest in a very good idea. And that really matters because, again, I started the conversation off with limited staff time, everybody's busy, and really limited resources that we're constantly competing for to try to make our utility better, and we want the best ideas to rise to the top. I did mention that all ideas, even if they're good ideas and they do get to move forward, we do have a SharePoint site that allows anybody starting the organization, or if they've been here for 30 years, what the heck is my organization doing about such and such? They can go in SharePoint now and find out, where before they would have to ask people, which, I don't know, is silly. We've broken it up into resource-specific pages, and so not only are we talking about innovation, but we're actually teaching people about these concepts, about nutrient removal and nutrient recovery, probably something they never thought about in the past. And now they can kind of see that what they do is not, anybody can see, is what we do is not just wastewater treatment, but it really is resource recovery, and we provide examples of how we already do that, and we're already innovating.
Question?
Yeah.
Is that SharePoint available to the general public?
No. No, just because we're a utility and we have to be worried about people looking at our plant schematics, and we have a lot of internal information because a lot of these prioritization members have gone really in depth on are they compatible with our process. And I mentioned this topic card library. We have hundreds of ideas, and a lot of times we find that people come back from WEFTEC and other conferences with the same idea. And in the past, we would all run around worrying about that idea, when 2 years ago, we did the same thing. We looked at that idea and it went nowhere, and now but that was one group, and this other group is like, I have a really great idea. Now they can just find out if we've actually looked into it and where it landed. And again, if things have changed, great, we'll reassess it.
So I think what Karri, what I walk away from what Karri's talking about is that if you innovate, you need a process. You need a process where you have your idea, the topic. You have a prioritization memo, and then you have a template to how you present, and it's consistent. So it's a process that you kind of step through to innovate. So what Tim and I can do is walk through how we innovate here at EBMUD. We'll try to connect some stuff to what you were saying, and then we can have some questions at the very end. All right, let's get the boring slides in the beginning. This is our water. We always do this for everybody, but if you are an EBMUD customer, our water is great. It comes from the mountains, goes across the 90 miles of aqueduct, come to our service area. Key thing to remember there is we have about 4,000 miles of pipe in our system, 4,000 miles of distribution pipe. So, we've been putting pipe in the ground for a long time, from the 1880s. Up until now. We've been innovating all throughout that time period. Innovation is kind of a trendy term these days. You hear about it all the time. Oh, let's go innovate and do some new stuff. People have been innovating for years. This is how we put pipe in the ground years and years ago. There's been lots of innovations over the period of time. Gone from shovels and pickaxes. There's no hard hats here. To what we're doing today, to what you see in the field. So problem statement too, I think Karri talked about, if you're going to innovate, you have to know what the problem is you're trying to solve. Just don't go innovate just for the sake of innovating, okay? So coming up with a problem, getting a process, and then we'll have some takeaways at the end. So here's our system. If you zoom right into our system, our 4,000 miles of pipe, you can see the materials that we have there: asbestos, cement, and cast iron. Cast iron's our worst performing pipe. got about 55 breaks per 100 miles per year. That's a lot. Asbestos cements at about 20 breaks per 100 miles per year. Also a lot, and kind of teetering on the edge. I don't know what's going to happen with our AC pipe. I don't think anyone really knows right now. It could start to spike up, and then we're going to have a lot more main breaks. But that's our system right there. So what's the problem? The problem is we have too many main breaks right now. And we wanted to ramp up our replacement rate, and we wanted to do it in an innovative way. Here's a shot of one of our main breaks. You know, we have anywhere from 800 to 1,000 main breaks per year. There are about 28, 29 maintenance crews out there fixing these main breaks. So we need to bring that main break number down. And this is what we've done over the historical, since 1995. The blue is how much pipe we replaced. And the key takeaway there is that you can see we kind of hovered around that 10-mile mark up until about 2010, 2011, where we started to move up. And so we're ramping up our pipeline replacement rate. We're getting that old bad cast iron out of our system. And the goal is to bring those main breaks down. So I hope you get the problem statement. It's all about main breaks, ramping up our pipeline replacement rate so we can bring those main breaks down. You know, this slide worked a couple of years ago really well, but this team is not off to a good start right now. Sometimes when you innovate, you need to look for inspiration in other venues. You know, 5 years ago, you know, the Warriors, I don't know, if you're a basketball fan, great. If not, it's okay. Look, the Warriors changed the game. Everybody is doing what the Warriors are doing right now. Did they innovate? You could probably argue that they innovated. You know, Steph Curry changed the way he played the game. He started shooting beyond the three-point line, and they also really focused on teamwork. He's not a selfish NBA player. He's all about team and collaboration. So we drew some inspiration from the Warriors 5 years ago. You know, that chart right there shows everybody else doing three-pointers. That line above there is what Steph Curry did one year.
Yeah.
So he changed the game. He went above and beyond. And look at what he did in terms of his production.
Now we need another Warrior to change the game. So, you know, one of the steps, first steps we took, a very basic approach, was EBMUD. We have two different facilities. Right here where you are now is where all of our engineering group is stationed, and then across the town, West Oakland, is where all our construction and maintenance staff are located. And even though they're not very far apart, we had a very siloed approach where engineering did their body of work and construction did theirs, and there was very little collaboration or discussion, you know, between the two departments in terms of a common thing they're working on, which is to replace these pipes. So that was, you know, really step one was just to move engineering staff into the construction and maintenance work zone. I think the next slide will show that.
So I'm an engineer. I'm in the engineering group. Tim's a construction maintenance superintendent in the O&M group. They brought the two of us together to start this whole thing 5 years ago. I was at this downtown building. Tim's over there in our construction maintenance center. We brought everybody together to make teamwork and collaboration at the heart of innovation.
The best way I can describe it is we used to receive drawings from engineering group, look at them, kind of crumble them up, throw them to the side, and install the pipe, you know, however we thought was the best way. So having that collaboration is important. And I'm using those terms loosely, but essentially there was not a lot of collaboration.
Actually, some of the guys still do that, and we're still kind of a process.
So this is
in the same space now?
Yeah, so
actually right here is a good example where this pipeline rebuild team that we have consists of construction staff, engineering staff. It also has pipeline designers, management analysts, our construction inspection group, general pipe supervisors, all working together in one common workspace. Everybody, you know, basically going back to the Steph Curry example, creating that teamwork and collaboration is like the key of the whole thing. Having voices heard at the table that represent different aspects of you know, the challenges that we have. Just having all the stakeholders in one common place, we can quickly resolve any type of challenge we have by just walking across, you know, from your desk to the next and getting those answers and getting that information out to the field so our crews can apply that immediately out on the site.
So I had my whole group here in this building. I moved the whole group over to our Adeline office over on West Grand at Adeline. And we created this open collaborative workspace. So we have engineers, designers, CI, survey, construction inspection, survey, pipeline construction. We're all there. We all start our day there. We problem solve together. It's one of the greatest things I think that we've done to help the innovation process is we put people next to each other with the adjacency.
The other you know, thing to close this out is one thing to point out is just it's one of the first times in my career I've ever worked with a cross section of staff. Typically, most people work in the department that has all the workers, all the employees are focused on the same task, and just having that blend of experience and perspectives is super beneficial when you're trying to innovate.
So this is really what we've created. So when I talk about a process, you know, Carrie's got a process at San Francisco. We didn't have this process 5 years ago when we put everybody together in the same area and started coming through and coming up with these ideas. This process basically evolved into what you see up here. And it's a workflow where we look at the status quo, we look at how we're doing our work right now, we brainstorm, we come up with the ideas, we come up with those topic cards, we come up with a plan. How are we going to actually try or test this? We actually go out and pilot it. We try and test it. We evaluate. So this is one of the most important points is that you got to figure out if it's really working, if it's successful, and that needs metrics. You need data to actually compare your testing versus your status quo to actually prove that your innovation is successful. Then there's the refine process. There's always going to be a refine process. You're never going to get it right the first time. And so there's kind of a back and forth between testing and evaluation and coming up with your final recommendation. And we do have a recommendation memo at the very end of the day, which is very structured. It's a very consistent structure so that all of our innovation ideas look the same, kind of like your prioritization memo. We have background information, the problem we're solving, the idea. What's the value that we're going to get out of it? What are the challenges we're going to face? How are we going to implement it? What are our findings? So what are our actual results? And then our conclusions, recommendations. So every innovation, every idea follows that process and follows this workflow.
The bottom line is just having a standardized approach to apply all of your innovative ideas towards, so you have a consistent way to measure and evaluate and then ultimately arrive at the outcome.
So,
do you have a template for each of those steps?
Yeah, well, not so much a template, but we're going to walk through each step in the coming slides to allow you to have a better understanding of each point. And,
so,
you know, the other thing
you go on this one.
Is this innovation cycle wasn't realized at the onset of our, you know, we talked about merging the two departments together and starting a process. We didn't start day one with the innovation cycle. This was realized over time that we needed a consistent approach, and so it was developed, and the outcome was just this. So the first step is your status quo, and that's where an agency like ours, you know, been around a long time. We have very fixed processes. We have employees that are very good at the work that they're doing, and you know, it's looking at all of that work. We need to get ahead of this main break problem, right, and replace more pipes. We have to look at how we're doing our business and how can we do it better, more efficiently, more cost, more cost productive, and so forth. So it's really important to understand your status quo before you jump into any kind of change, and that's mapping out all the the workflows that are used currently in your agency, all the work processes and so forth, map those out, talk to all the stakeholders, both upstream and downstream of the process, and make sure you really have a clear understanding of exactly what you're doing right now in your status quo before you try to make that change.
And then you get buy-in. So like Tim's saying, you diagram it all out, you clarify it, and then you get everybody to agree on what the status quo is. And what we discovered in this whole process is that there are a variety of ideas as to what the status quo really is for a lot of different things that you're doing. Everybody does things a little bit differently. The key is to clarify and get buy-in. This is how we actually do our work right now. You need a baseline. You got to compare something against an innovation against your baseline to really prove that it's successful. And this is kind of creating that baseline.
And that picture there is just a status quo pipeline design. Typically what engineering would produce, we would utilize out in the field to replace the pipe. So very congested drawing with a lot of information, just builds up over time, and all of a sudden that becomes the norm. And you know, again, fixed processes over a long period of time, people just start to add layers on it, and pretty soon you end up with something like that.
Yeah, so this is just an example of something we've worked through the whole process. This is the design process. We clarified the status quo. We figured out all the different steps that go into a design. That's what it looked like a few years ago. We came up with some ideas to streamline the process, to make it simpler, and to make it work for our construction staff so they won't crumple up our design drawings and toss them away. And this is what we came up with. It's a much easier to read drawing. It gives you the right information to put the pipe in the ground. And we're continually refining this and making it better. But this has already gone through the process.
And that's an example where we became 50% more efficient in creating our designs, and with that, half the cost. So that's an example of how that innovation made improvement. The next is, you know, you take your status quo and you brainstorm what's possible, what are some ideas, where is some low-hanging fruit and opportunities where we can get better, more efficient, and so forth. And again, that's being transparent with all the stakeholders that help with the status quo, and learning, you know, where's the best opportunity to focus, and where can we get the biggest gain by running this through the innovation cycle. So again, it's all about a collaborative effort, making sure you understand all the perspectives from all the different stakeholders before you jump into some sort of test.
Yeah, and this is where when we got the collaboration and teamwork together, this is really engineering listening to our field staff with their ideas as to how we can improve our work in the field. 90% of our budget for putting pipe in the ground is actually the construction work. You know, 10% or a little bit less is the planning and design. Let's get the ideas from the field. They're the ones, our construction staff, our guys are the ones doing things on a daily basis. Let's listen to their ideas. Let's empower them so their voices are heard. We'll listen to their ideas, we'll consider them, and then we'll try it. We'll pilot them. We're not going to pilot everything, because I think, as Karri said, you kind of have to make some tough decisions there as to what you try. You just can't do everything that everybody wants to do. But you got to have a process for really vetting those ideas.
Do you have a mechanism for holding, kind of what Karri was saying? So you're doing design here, you can't try everything. Do you capture those other good ideas for later examination?
Mm-hmm. Yeah. We have a whole spreadsheet with lots of different ideas, you know, broken up into different tabs. So we keep a log of all that.
Okay.
You got to stay flexible, adaptive in the whole process. You know, maybe it's going to come back. You know, yeah.
How much do you save on outside consultant fees doing this?
How much do we save on outside consulting fees? So we do all of this work ourselves.
It's all in-house. You wouldn't have had that expense in the past.
Yeah.
Okay.
Yeah, we do all the planning, design, construction, as-builting, mapping ourselves. This is all our small distribution main, our 6, 8-inch, up to 16-inch in diameter. We contract out our large diameter work, anything 24-inch in diameter and above. And sometimes we'll hire a consultant to help with design there. But this is all about our distribution pipes.
You know, we have we have 12 crews or 11 crews, soon to be 12 crews, and we replace 17 miles a year. And that's we're about $2.5 million a mile. Yeah, 2.5 million per mile. So it gives you some perspective. We can gain some efficiencies anywhere and trim that cost down. It's a significant savings.
So San Francisco is 5 million a mile, just FYI.
Oh, okay. Yeah.
That's because
That's a
I
real
think
estate.
your concrete pavement restoration is what really takes it off the charts. So this is an example here. This is an asbestos cement pipe that was lined with cured in place pipe with a product called Aqua Pipe. So we had an idea years ago. Let's give our AC pipe a little bit longer life. I mentioned at the very beginning it's got a lower main break rate than our cast iron. Well, if we can take our AC pipe and we can line it and we can give it an extended life, then we can focus our efforts on the cast iron pipe. And so we did 2.5 miles of renewal with Aqua Pipe product in our AC pipe. Again, it went through this whole process. The key there is that we took some risks. We're the first utility in the country to go and do such a project with the AC pipe, aligning it with Aqua Pipe. And we have a whole nother presentation on that. But that's just another example of what went through the cycle. The next thing here is that you got to have a plan. After you come up with the idea, you got to have a plan. You have to really clarify what's the value that it's going to provide versus your status quo. What are the challenges for implementation? And then you have to build allies. We're a large organization. I think it's true in a small organization too. If you have an idea, you've got to build a group of people and get them behind your idea to really push it forward. So that's part of the work plan too. You got to go out and sell it. You got to convince stakeholders, convince everybody else in your organization that this is a good idea. You're not going to convince everybody, but I think Tim and I went to a seminar about a month ago where if you can get 50 to 60% of your stakeholder group to kind of buy into your idea, you're headed in the right direction.
And that's one of the most challenging parts of innovation is getting that buy-in. People warmed up to the idea of change or at least testing some idea for change. So in the example of the Aqua Pipe we just showed you, we had some maintenance crews that we heard a lot of pushback about how are we going to maintain this new pipe and all these things. And so we took the most vocal, outspoken crews and foremen and we brought them into the process and we actually teamed them with the Aqua Pipe installers to learn how to maintain it and test it and do leak detection work on it. And it turns out they once they got their hands on it and got familiar with it and understood more, basically you want to educate your staff on why it's a good idea. And then allow them to participate, get their hands on it, let them work with it, and then that'll help you gain buy-in for any change you're trying to make.
And the example up here right now is that we're using machine learning right now to visualize our risk in our pipeline system. So about 4 years ago, a company, Silicon Valley startup, came to us and said, hey, can we work together with you, collaborate with you on developing a product? And we were open to that. We shared our data with them. And at the end of the day, they created a product that uses machine learning to layer all of our data and then look for patterns and correlations in terms of where our risk is in our pipeline system. And you end up with a map that has all your red pipe, that's the pipe that you need to go out and replace. That's the pipe that's the most likely to fail in the next 5 years, and then the orange pipe. So this example helps us create our pipeline replacement clusters right now. Yeah.
Just curious, did you use consequence of failure for this as well?
We're separating out likelihood of failure and consequence of failure. I think you see a lot of people around multiplying the two together to get an overall risk. And I don't think that's the right approach. I think you need to separate out the likelihood of failure, start there, And then when you get into a project, then you drill into consequence of failure to refine the project extents. Consequence of failure can actually dilute and not give you the result I think you want.
Second question. How much of this was based on actual condition assessment versus just risk model?
None of it. That's something that I want to work on creating more of here. It's more of a condition assessment program.
So the next step is to actually take that work plan out in the field and apply it and work through it. So this is an example, looking at our crew there, just using new materials that are, in this case, self-restrained fittings that lock together. Typically, a connection like that would take a welder and take a crew most of the day to fabricate and install. And just using innovative materials like this, they pop together. The whole thing's assembled in about a half hour with 2 people. So that's an example of how we've gained efficiency just by testing new products, testing new materials, being flexible and adaptive to these changes, and testing, getting out in the field and working through it. There's also, I'm not going to say everything's gone perfectly in these work, as we pilot these things. There's one thing to think of an idea, work through the work plan, and at the table it seems like a great thing that's going to go smoothly, but once you pilot it, there's challenges with using new materials, for example, not having the right training or tools or processes in place. So it takes time to kind of go through this work plan, and you have to be willing to, again, take those risks that Dave pointed out earlier, work through those, stick with the work plan, go all the way through it, and capture, the pros and cons as you go. The other challenge with something like this as you're piloting is, everybody, your KPIs, your goals don't change. So you're still expected to produce, and meanwhile you're testing, so your productivity rates and all those things suffer while you're learning. And at the same time, you still have to deliver on the other end. So you have to be mindful that that's not an easy process, but it's certainly worth working through, because that's how you gain your efficiencies.
And then you got to have the right metrics in place to measure how you're doing. So we have one staff person 100% devoted to metrics. So for every pilot project that we're doing, every pipeline replacement job that we're doing out in the field, one person, 100% of their time is resourced to collect the data and track the metrics. You've got to make sure that that's a priority for you if you're going to do this. Yeah.
Alex, the two was just mentioned that, you say, okay, we're only spend 10, maybe 20% of our time sinking our resources into a pilot, but we got to keep our eye on the ball and do 80% of our time that's
one thing, I mentioned we have 11 crews, so we would try not to launch too many pilots at the same time, and maybe just dedicated to a crew or 2. So the bulk of our teams are still being as productive as they were while the other teams are learning. The other important thing is to mix up who gets their hands on the pilot. You don't want to have a special group of crews that gets to test everything. That was certainly something we realized over time. Is initially we had 2 dedicated crews tasked with piloting, testing, and then we started to realize that's not a good approach, and got some pushback from others that didn't get to participate. So fast forward to today, all 11 crews that we have are all equally able and have participated in pilot testing, and that's really important to consider.
The story behind this too. I mean, the guy in the middle doing this with the blue fittings there. That was an idea that came up about 4 years ago, and we can't keep those in stock right now. We have such buy-in from our field staff for installing these for any offsets or even our whole replacement projects. This is one of the game changers for us in terms of improving our efficiencies and getting more pipe in the ground and getting real buy-in from our field staff. Yeah.
Well, what if, it sounds great, right? You've got a new product, it's faster, better, whatever, but you don't have the test of history. I mean,
Great
so what do you do with that?
So yeah, we are very careful, EBMUD is very careful at approving and adopting, new materials. So we make sure that we not only test it, we research, make sure we understand the performance quality from the vendors, what the vendors are telling you. But then last, we've actually teamed with Cornell University, which is the premier seismic testing lab in Ithaca, New York, as well as Boulder, UC Boulder, another pipe testing lab. So we take the pipe materials, we test them ourselves in terms of installing and whatnot. We work with the manufacturers to understand the engineering capabilities of the materials. And last, we take those materials to those third-party testing labs like Cornell and Boulder, and Dave and I actually visit those sites and watch those tests ourselves and get those reports to make sure that we're, when we recommend a material, it's proven across a number of lines.
I mean, like that's going to stay in the ground a long time.
Correct. 150 years.
Yeah, I mean, I can't emphasize more how important it is to third-party testing. You get vendors and manufacturers, and they'll come and they'll try to sell you a product, and they'll say it's going to last this long, and it's this great, and meets all these standards. And you can walk away with the spec sheets, and that's all good. But you need to go do your own testing to back up that information. We always do that.
One thing I failed to mention is, in addition to all those things I mentioned, we also team with other water utilities, LA Water, Las Vegas Valley Water, and San Francisco PUC, et cetera, to make sure that we're learning from one another, and as well. So we couple all that information together before we arrive. And then ultimately, inside EBMUD, there's a final series of approvals that we go through. So it's carefully vetted before we say we're going to start dropping those fittings in the ground.
Yeah, I mentioned the aqua pipe a few slides ago, the cured in place liner. So Tim and I are traveling back to Cornell first week in December. SFPUC is sending 3 or 4 folks. LADWP is sending 4 staff members. So the 3 utilities are all going back to Cornell to see the testing of aqua pipe in their seismic lab right there. So
Well, that was great that you're able to pool resources to do those things. It is a challenge for us. But the seismic resilience, of course, is something that you can test in the present conditions. The other ones that are difficult to test for are longevity and potential water quality impacts. I'm just wondering if you were able to, how you were able to satisfy those questions without having decades of track record to tap into.
yeah, that's always that's a good question, and you can't. It's always hard to get to a real complete answer.
Yeah.
With all of that, but you can look at. So some materials go under fatigue testing, cyclic testing over and over again with different loading, and can estimate how long a material is going to last from that. You can take that with a new product, and that's what you have, but you don't have the track record. The cast iron pipe that we have in our ground from 1900 has the track record. That stuff lasts 120 years. That's there. So we're actually going to be doing a lot more ductile iron pipe installation in the future, as opposed to plastic. So tough one.
What kind of, that's PVC, right? So is it C900?
Yeah.
That's not C900.
Yeah, so, example, we tested a number of different strains of pipe, ductile, PVC, et cetera. So in our pilots, we've tested PVCO, which is a thin wall PVC, and IPVC. So in that case, that's IPVC coupled with RCT.
What are those couplings? I've never seen them.
It's called an RCT, and I can talk to you afterwards.
It's a ductile iron RCT if you Google it.
Basically like a self-locking fitting, drop it in, got some metal teeth that check into the
What's for PVC?
Yeah. And I'll get you up after. I'll send you a video of some tests that we saw.
Appreciate that. Thank you.
So I'm kind of running out of time here. So evaluation always really important. You gotta figure out what you're learning. You've got to look at the metrics. Really important part here is to communicate to stakeholders how things are going. You can't, you go pilot, you go innovate, and you go testing. You've got to remember your people, your stakeholders, to communicate all the information to. When you're in the refine mode, you got to question Are we solving the problem that we set out to solve? Is there anything else we can tweak to fine tune it? And then to continually look for that improvement. Are we getting the most out of this innovation right now? So this is an important part when you're refining everything. And the recommendation phase is really putting everything together. And I talked earlier about how we have a memo that is a really structured memo that documents everything, the idea, the value, the challenges, our findings and conclusion. Then you go to the next part, which is maybe even the most difficult part, is to how you actually change and get everybody else on board, which is a completely separate next step, which is not what we're going to go into, but that's kind of where we're at right now. We have 10 to 15 different case studies where we've done this innovation cycle over the course of the last 4 years, and right now we're trying to get the rest of our stakeholders and folks here at EBMUD on board with a lot of the change that we're recommending.
I have a question.
Yeah.
When you say getting your stakeholders on board, does that include outside agencies? And
No.
who are you sharing your findings with, and how does that benefit the rest of society?
All internal.
Okay.
So stakeholders are all internal.
Sure.
All of the different groups, we have 10 to 15 different groups that touch a pipeline replacement project. So, getting planning, survey, construction inspection, design, maintenance, construction, purchasing, asset management, getting everybody on board with an idea, an innovation to change, and then change the way we're doing our work. That's what I'm talking about in terms of stakeholders.
Just curious, anybody in here a manager? All right, well, no slight to you guys, but one of the biggest challenges is getting the management team to buy into these changes that are responsible for the respective groups, and because from there it cascades down to the staff, right? And so like Dave mentioned, we can prove we can be more efficient, more innovative, and we've demonstrated it to you guys just now. The next thing is to scale it up, and in order to scale something up, you have to have buy-in across all the lines up top of the organization down, and that's exactly where we're at right now.
Then I think we mentioned this along the way too, it's really good not to just stay focused internally, but get out and talk to other agencies about what they're doing. If we all had a consistent way to pilot and innovate, we could all share information and utilize that information. We all don't have to go test everything and do it over and over again. And then collaborate with your universities. Our main takeaways here is you need a process to innovate. You need management and board support. We actually have a couple of directors that tell us failure is okay. We expect you to fail because that's how you're learning. So the two of us, Tim and I, are getting that from our directors. You need the freedom, you need the flexibility, the time to do it, and then you've got to collaborate with teamwork has to be at the core of everything. Those are really our main takeaways.